Hello everyone, good morning, and today I am going to present Capstone 5, that is uh, to write the solutions for the top 50 interview questions out of 80, and going to explain only 5 for video purpose. And these are all the questions that were given for writing the solutions for all the top 80. Uh, Before answering all the questions, what I did is I went through all those 80 questions and sorted top 50 questions that can be answered in an interview or that have the probability of asking in an interview. So based on that, I also given few specific numerics, and which is the original question as well in the top 80 questions. As you can see, there are few questions where the numbers and the original questions are not same because I've arranged in an order from top 50 out of 80. So based on that, I've named the questions. And yes, let's go to the uh, questions. These are all the top 50 questions that we can answer. For each and every question, I gave two basic important questions. I didn't want to be like a single word answer, or I didn't want to be as a very lengthy paragraph, because when we are preparing for an interview, the all the topics must be precise and concise, because we cannot remember all the topics and every topic in a specific end-to-end manner. There should be one specific point or one specific sentence where we are able to remember all the topic. That is the main concept that I wanted to show in the 2-point structure. That is why I gave 2 points for each and every question for all the 50 questions. As you can see, each and every question has 2 points, and each question is from different is randomly allocated for the top 50 structure. These are all the top 50 questions, as we can see here. Okay, let's go and analyze 5 different questions. Coming to the first question, what is the dot product of two vectors? Let me start with a question. How does a recommendation system know that me and another user have a similar taste in something? That comes from the dot product result. When a dot product result multiplies with their corresponding components and sum them up, mathematically speaking, it does the dot product modulus of A times modulus of B and dot cos theta value. If that value is matching with the other user as well, it gives us a positive value. If the result is positive, then we can say that I and another user have a corresponding relationship where our taste matches. If there is if the value is 0, then we can say that we don't have our tastes are neutral. I mean, it is not overlapping or it is not disliking with each other. If the value is negative, if the dot value is negative, then we can say that our interests to totally misalign with each other. Okay, so in coming to the real world application, we can say that every mechanism and every neural network layer will use dot product value. Without dot product value, modern AI system will not exist, because of all the tastes and all the inputs from the user will be calculating on dot product, so that it can give us a fruitful result for the user. Okay, and coming to the next question, let's go with what is conditional probability? In a scenario, let us take a scenario. Uh, a, a patient will test positive for a disease, and how worried should the patient be, or how accurate is the disease for the patient? That depends upon conditional probability. Like, has the by asking few questions to the patients, we can say that how the treatment should be efficient, or how quick we must proceed with the treatment. Like, we can ask the patient, like, has this already happened to the person before, or how probability is that something else is happening, like fever and cough are correlated to each other. How frequently cough and cold uh, are likely to come together for a patient. uh, Formally, how probable of A, given that probable uh, B, we can say that probability of A given B is equal to probability of A intersection B divided by probability of B, which means probability of A is supposedly what is the probability of A when B is to occur is equal to probability of A intersection B, which means which where there's a common section for both, where A and B is to occur, divided by the probability of B. This is the formula of conditional probability. Like, when we can take a medical example, like I've told you earlier, if a test is 99% accurate, the disease will affect only like 1 out of 100 people, but the test is still uh, a false alarm for the 1%. If we are comparing to that 1%, the test is still a false positive. Like, for the other 99% of people, it might be a true outcome. But if you are considering that where the test might fail when giving a conditional probability, we should also consider that 1% of population as well. Okay. uh, then also, coming to the real world examples, we can say that spam filtering and fraud detection system and medical diagnosis that I've told you earlier regarding the fever and cough example. Uh, these can all consider as probable conditional probability. Okay, and coming to the next question, what are the measures of central tendencies? Okay, so let us go with a question again. If somebody told you that the average salary of company is around 80 lakhs per year, uh, would you would we believe that every employee in the company is equally paid or well paid? Probably not, because we know what the standards of a company are, and what is the price range and salary range for each employer. The average salary range does not mean that each and every employee is compulsorily and mandatorily getting around the salary range. Okay, that is where our central tendencies lies. We have three main central tendency measures, that is mean, which adds up uh, all the values and divides with the number of count, which is the which is also called average. Sum of products by the number of products is the formula for mean. And let us go with the another one, that is median, which gives up the middle value of the data. This can be used when we want to restrain all the outlier values. Mode, in mode, the third one is mode, which is also known as the most frequent occurring value in the whole data set. Okay. uh, in the salary example that I've told earlier, that if 80 lakhs is the average, what if the CEO is alone earning like 10 to 15 crores per year, uh, and a normal average employee is earning like 6 lakhs per annum. So the 80 average comes where we add up all the sums of all the salaries for the employees divided by the number of employees. That's where we get 80 lakhs per year, and not everyone is equally paid 80 lakhs per annum. In if we want to take the if we want to eradicate all the outliers and want to get the median value, eradicating outliers, that's what gives the more honest value and more honest picture of how the company is performing per year. In the if I want to say about other few examples of the real world life, we can also say that in data processing, uh, choosing choosing the wrong measure of central tendencies will for imputing the values can change the result, and may also give us the false output also, where mean imputation for a skewed data can be a common example for that is done in the most industrial data transmission values. So in mean, median, and mode, it is not essential to pick only median, only mean, or only mode for the data imputation. After considering the values and how much is the imputation value and how much is the null value percentage for the column or for a data set, we should perform the central tendencies accordingly. If we perform, if there are outliers in a data set and we perform mean uh, mean for that column, it does not make any sense and gives the false results for sure, because after eliminating outliers, as I've told you before, median gives us the truth value, or more honest value for a column. If there is no skewed data, and there is no left skewed value, or there is no right skewed value, mean can be taken as central tendencies for that column. Okay, so based on what uh, the imputation result is, that central tendency must be performed for a fruitful outcome. Okay, and yeah, coming to the fourth question, how do you detect and handle outliers? Imagine a prediction model where one data point says the house is sold for like uh, 20 crores, or say, let's say that is a highly impeccable value where a house is sold for like 600 crores or so. Do we trust the value or do we remove the value? Because buying a house for 600 crores is like an absurd value. So that decision can break the model. So we have that in the detection techniques, there are, the first is called IQR, which is interquartile range, where we calculate Q1 and Q3, where those are the results of quartile 1 and quartile 3. Uh, Coming to that, any result beyond 1.5 times the IQR range, uh, in between IQR plus or minus 1.5 times Q3 will be flagged as an outlier. So when we are considering three standard deviations in the normal distribution graph, there are the result and the result of one standard deviation, two standard deviation, and three standard deviation. Most of the data will be most of the values will be lying in the three standard deviation range. That is what our data says. So if the value is outside this three quartile IQR range, then we can eliminate the values. These outliers can be eliminated. And second, z-scores. If any data point is this is what I've told you, that the three standard deviation one from the mean, it is considered as extreme. So with this is called a z-score result. If any point is outside this z-score result, once detected, we have options whether to point it as a data error or cap the value using other methods. We can choose to remove the values or reduce the cap value or the outlier value to the maximum value of the standard deviation result. Coming to the real world example, in fraud detection, our outliers are the signal, whether based on the signal we want to remove the uh, whether we want to remove it or not. Also, in a regression model, when predicting the delivery times of the product, one extreme delay can destroy our accuracy. Like the context will determine the treatment. And coming to the fifth question, what is empirical rule 65, 95, and 99.7? Okay. Uh, what if I told you that a student scored 145 on an IQ test and the mean is 100 and the standard deviation is 15. Without any calculations, can we say that how rare is that, or how good the value is? No. With empirical rule, we can, because the 68, 95, and 97, 99.7, these values are typically saying, if I want to put it in a sentence, 68% of the data from the mean will fall in the one standard deviation from the mean. 95% data will fall in within the two standard deviations from the mean, and 99.7% of data will fall between the three standard deviations of from the mean. So if any value is within these values, we can consider this as a normal data, and most of the data, like 99.7% of the data, is what we are calculating for the results or something. So if we need not calculate fourth deviation or fifth deviation, because it would only result to 0.2% of 0.2% of data or 0.1% of data. We need not take much uh, stress on calculating or proving only 2%, 2% of 0.2% of data. Okay. In our IQ example, if 145 is the value, if we want to find from 100 and the standard deviation is 15, if the one standard deviation is 15, then three standard deviation is 45. 3 into 15 is 45. So 145 is lying between this three standard deviation result. So this is a fruitful result and it is not considered to be as an anomaly. Okay. So the person would probably lie in 95% data to 99.7% of data. So he is between the uh, result only. Okay. Considering a real, if we want to consider real value or real life examples, this rule can be used in controlling quality and anomaly detection to avoid, and whether A by B testing can be interpreted, or setting alert threshold in monitoring systems. Okay. So these are 5 questions where I wanted 5 of these 50 questions. I wanted to show where our data would and our explanation would lie. These are all the 50 questions, and this is what I wanted to present the video link. And while the top 50 questions are also important, I cannot say that the other 30 questions would not be answered or would not be questioned. As I've told you, the probability of answering those 50 questions is more, and probability of answering these 30 questions is also there and not zero. So I also answered all the other 80 questions as well for our, just as a uh, uh, the probability would not be less. I also answered and gave a few 2 point for all 2 pointers for all these other 30 questions as well. Thank you.